about the application of statistics in historical research. How quantitative methods help historians to interpret the past. The total analysis has been reflected by this poster. Okay, so there are 30, perhaps 30 posters, 30 images are there, 30 cells are there. The total analysis has been prepared in this way. Okay, so just let me first explain the diagram, because what I feel that if we try to understand in statistics in terms of diagram, it will be good for the listeners also, and the scholar also. So I can start in this way. The statistics transforms historical records into measurable evidence. Historical data becomes meaningful through statistical analysis. The military roles, the trade records, the tax registers, census records. So mostly the research, the data that are required for the historical research is the reports, records, like this, registers, secondary data. Okay. So descriptive statistics, as we know, statistics can be divided into two parts. One is descriptive statistics, another is inferential statistics. So what the information or what the data tells at this moment is descriptive statistics, and on the basis of data, if we generalize for the whole population, if we predict for the whole population, this is known as from the sample data. Whenever we generalize for the whole population, then it is known as inferential statistics. And the descriptive statistics, the main emphasis is given on measures of central tendency and mean. Arithmetic mean is the most important measure of central tendency. It is the average, it shows the average historical value at this juncture. And another important term that is used in descriptive statistics, especially the measures of central tendency, is the median, which identifies the middle observation. The mode reveals the most common category. Okay, most common category it reveals. For example, in a particular village, if 120 farmers are there, weaver 45, blacksmith 15, potter 20, so we can say the maximum number of farmers are in that village. Okay, so the mode is the highest number of frequency. Another important term that is used in statistics and which can be applicable in various uses, for various uses in historical research, that is the standard deviation, which measures the variability. After calculating the mean, how the other values fluctuates or deviates with respect to the mean, and that is the measure of standard deviation. For example, in one empire or one time period, suppose the agricultural crop or production, if we take the mean of different years production or crop production or cultivation, and we can calculate mean, we can also calculate standard deviation. Similarly, in the another king's region or in different time periods, what is the standard deviation of the crop production. On the basis of this standard deviation, and if we compare that, suppose in country 1 the standard deviation is 1.6, and in country 2 the standard deviation is 31.6, then we can say the crop cultivation or crop production is more or less stable, and here in country 2 it is unstable. Now the researcher can find why the crop production is so unstable. Does there exist any in that time period, what are the main reasons of such kind of fluctuations, whether war taking place in the particular time during that time period, or famine or flood, what are the possible reasons for such kind of fluctuations. So this statistics, this measure can be used for analyzing such phenomena. Similarly, this is a pie chart. Pie chart is also one of the important tool that may be used by the researcher of history. Okay, the percentage compares part of the whole. Percentage is the part of the whole. Okay, for example, in a particular country, 60% are Hindus, 25% are Muslims, 15% are others. So through a diagram it can be explained very clearly. Similarly, growth rate, another statistical measure that is used later on, I can able to explain the in terms of quantitative measurement, or how can we able to calculate. So growth rate measures the historical change over time in 1800, 1850, 1900, 1950, 2000. Okay, whatever may be the data, it may be production, it may be tax or revenue collection, whatever it may be population growth. Okay, so if there is such kind of tendency, say we can say with respect to growth, we can able to say that the change over time. Similarly, time plot of the data also shows the long-term historical trend. Okay, long-term historical trend. This is the direct data. If we plot the direct data, this is the growth rate. This is a direct plot, and if it shows like this, ups and downs, but ultimately upward rising, so there is a clear tendency of upward rising trend. Okay, for that particular phenomenon. Similarly, another important term that is used in historical research, or that is correlation and regression. These are the two important tools that the researcher can able to use. Actually, correlation means, in terms of statistical language, it is the degree of linear relationship. Through this diagram, it is also clear if we say that the amount of rainfall and the amount of crop production, okay, they are related. So to what is the degree of such kind of relationship, we can be able to measure such kind of relationship. That means whether with the increases of one, another also increases, or with the increases of one, another decreases. So it's the correlation coefficient. Actually its value is -1 to 1. If the value is 0, it implies there is no relation between the two variables. Okay, amount of rainfall and the amount of agricultural production. So if it is -1, that means with the increases of one, another one also declines. If it is +1, with the increases of one, another one perfectly increases. Okay, so such kind of analysis can be portrayed with the help of, with the applications of correlation. Similarly, for prediction, positive correlation indicates variables move together. Okay, so if we plot this is known as scatter plot. This scatter plot is known as also takes important part in graphical analysis. Okay, so this is scatter plot, where the rainfall is being measured in the horizontal axis. This is horizontal axis, and this is vertical axis, crop yield. Okay, so every year if we take 1 point implies 2 coordinate, 1 point implies 2 coordinate, amount of rainfall here and crop yield here. Okay, so vertical axis measures crop yield and the horizontal axis measures rainfall. Similarly, for any point, we can say that in this point implies when the rainfall is this, the crop yield is like this. Okay, so all the points shows how much amount of rainfall and what is the crop yield. So the regression analysis, regression tells us on average, okay, on average what is the crop yield for a particular value of rainfall, because here we can see that this amount of rainfall may yield this amount of crop, or this amount of crop in another areas. Okay, so there it is possible that for a limited amount of rainfall there may be different types of crop yield, because crop yield not only depends on rainfall. There are so many factors that are affecting the crop yield. Maybe fertility of land or soil is one of the important factors. So whatever it may be, for a particular level of rainfall there may be many yield, crop yield. So the regression analysis tells us that what is the average, or the mean value or average of crop yield for a particular level of rainfall. When the rainfall is this, what is the average value? On an average, what is the average value of crop yield? Similarly, when the rainfall is this amount, what is the average value? So all the points on the red line shows that predicted value, or on what is the mean value or average value of crop yield for a particular level of rainfall. So this is the regression analysis. I'll tell in detail later on, but for this moment just have a look on this diagram. Okay, so this is correlation, degree of linear association, and this is regression. Regression for a particular value of one variable, what is the value of average value of the another variable. Another variable means this is dependent variable because crop yield depends on rainfall. Okay, so independent variable is taken generally on the horizontal axis and dependent variable on the vertical axis. Okay, regression estimates the cause and effect relationship. Actually, it is also true. The literacy rate here, the voters turnout with the help of, so there may be positive correlation. As the literacy rate increases, the voters, people are coming to cast their vote is also increases. So voters turnout percentage in terms of percentage may also increase. So this implies that there is positive association. The correlation tells us that there exists positive association with the increases of literacy, voter also increases, positive association. But the regression tells us that what is the level of, at what level of literacy, what is the average level of voter turnout, percentage of vote, what is the, if the literacy rate is this, what is the average level of percentage of voter turnout. Okay, so this is the difference between regression and correlation. Generally we write the regression by this equation. This is the dependent variable and this is the independent variable. So when there is only one independent variable, this is known as bivariate regression. There may be more than one independent variable, then it will be called as multiple regression. This A is called as intercept. Intercept means when the value of the independent variable is 0, when the value of the independent variable is 0, what is the value of dependent variable? For example, here, even if the literacy rate is 0, some people must go to cast their vote. So the intercept, this is the intercept value. Even if the independent variable is, the value of the independent variable is 0, what is the value of the dependent variable? And this beta is the slope. In terms of mathematical language, it is the slope. Slope. Mathematical language, if it is y, it is x, so it is dy dx. In this case, this is dy dx, means what will be the change of the dependent variable for a slight or 1 unit change of the independent variable. This is the beta. Beta means what is the change of the dependent variable with 1 unit change of increase of independent variable. Another important tool that is used in historical research, that is index number for compare historical change. For example, in the year 1900, if the price index is 100 and in 1950 it is 240, it implies there is 140% increase of price compared to the base period. Base period is always taken as 100. If you do not get 100 but you want to take 1900 as the base period, you have to convert it into 100. How? Suppose this is 120, so you have to convert it into 120. We have to divide by 120 by 120 into multiply by 100, so it will be converted into 100. So in this way all the term will be divided into 120 and multiplied by 100 to convert the base into 100. Since it is given as 100, so we don't need to change, we can compare. So from 1900 to 1950 there is 140% change in price if it is price index. So in this way price index also tells us some information that is relevant for the research. Base year compares. Okay. Another important tool of statistics, that is chi-square test. Chi-square test implies the association between the categories. Okay, association between categories, categorical variables relationship. It tells categorical variables relationship. Actually, this is chi-square independent test. So at this moment, just have a look that the two variable levels are education level and this is recruited or not recruited. So recruitment and the education level, recruitment or and not recruited. Actually the quantitative values we cannot able to use here. So what we need to convert that recruited yes or no. Okay, and here it is low, medium, high. That means education level is divided into 3 parts. Low means suppose up to class 8, less than 8. Medium means more than 8 and up to 12. High means up more than 12 and up to more than 12. Okay, whatever it may be, more than master degree or whatever it may be. So we have to classify into such category: low level of education, medium level of education, high level of education. But here we cannot able to put any kind of year, that 5 years of education, 6 years of education, 7 years of education. In this way you cannot able to put. Similarly, here also this is categorically whether it is recruited yes or no, and then from our sample or from our survey we got this. That means 40 candidates are there with low education and that recruited. Similarly, 60 candidates are not recruited with low education. Similarly, with medium education, 60 candidates recruited, but 40 candidates not recruited with medium education. A high education, 80 candidates recruited, but 20 candidates are not recruited. So this is known as contingency table, when this information reflects, each cell reflects two categories. For example, this cell 1, reflects low level of education and recruitment. Similarly, this cell low level of education and not recruited. In this way, whenever we put the information into this table, it is known as contingency table. Through this contingency table, we can able to apply this chi-square test. Okay, actually it is known as chi-square independence test, to investigate that does there exist any relationship between the education and the possibility of recruited in job or something like this. So how the total mechanism, how this chi-square test can be done, it will be explained later on, but for this moment just have a look how it looks. Is a categorical relationship, statistically testable. Okay, just to test the categorical relationship is education level and military recruitment. Recruitment means military recruitment. Okay, so this is one example, but many such examples are there with respect to the different issues. We can able to apply this tool. This is very important tool. Many researchers, even not only history but also in economics also, these chi-square tests are hugely used. Simple but beautiful. Large dataset reveals hidden historical patterns. Large dataset reveals hidden historical patterns. Similarly, statistics uncovers trends invisible to observations. We will come all these points later on. For this moment, just have a look this diagram. Historical comparison becomes objective. Kingdom A, kingdom B. So many kinds of tools so far we have discussed. This is known as bar diagram. This is known as trend analysis. We can able to make a comparison between two kingdoms or two countries, okay, two empire. So in this way, the historical research can be possible by applying statistical tool. Statistics explains economic history. Demographic analysis explains population change. This is the age structure 0 to 14, 15 to 29, 30 to 44, 45 to 59, 60, and more than 60. This is male. What is the male population, female population? So this will also help us to explain the pattern of demographic analysis, how the population changes. Price analysis reveals inflation and scarcity. The price analysis, price index, change in price analysis can help us to, or reveals the inflation and scarcity for that time period. Statistics measures agricultural stability, the crop production stability, as I already told. Trade statistics explains economic development. Trade statistics also important, okay, which shows which helps to explain the economic development, pattern of trade, why today we have a good relation, at what time in that time period, why we had good relation with that kind of other countries which had the trade relation with us, what are the different products that we are being exported, what are the products we are being imported. So all these trade relationship or trade data can explain the historical pattern of trade. Okay, so these will be very helpful. Similarly, election data reveals political behavior. Data strengthens historical interpretation. Past records become scientific evidence. To support the historical perspective. Statistics helps historians identify pattern, compare societies, measure change, and support historical conclusions with quantitative evidence. So these are the more or less the total study material for this lecture. Now let me start with the one. So this is the first part. I cannot able to explain all the things. Maybe there may be one or two, part 2, part 3, okay, for this type of analysis. So let me start with the descriptive one. The statistics has become an essential tool in historical research. It helps historians move beyond descriptive narratives and answer questions objectively by analyzing historical data such as census records, tax registers, prices, wages, trade statistics, military records, election results, and population data. Descriptive statistics. What is the purpose? Summarize the historical data. What are the methods? The methods are mean. These are the statistical methods that are going to be applied in historical analysis. What are the tools? Mean, median, mode, standard deviation, percentage, growth rate. From the very basic level, these are the very basic tool that may be applicable in historical research. So let me start with hypothetical example. Suppose a historian studies the population of a kingdom. Okay, so in the year 1800, 1810, 1820, so these are the year, this is the population in thousands. So how the historian can proceed? Historian calculates what is the mean population, 133,000. Calculating mean means sum of the population divided by the number of observations. Sum of observations divided by number of observations. In statistical language, this is summation x by n. Okay, in this is the mean population. Similarly, growth rate, population increased by 70% over 40 years. How can we calculate the growth rate? The final value minus first value divided by first value into 100. In this way, we can able to calculate. So 170 minus 100, okay, equals to 70 by 100 into 100. That means 70% over the 40 years. So in this way, the historian can able to calculate the growth rate of population. The kingdom experienced sustained demographic growth. Now mean. Arithmetic mean. The mean is the average value of all observations. It gives the central or typical value of a data set. What is the formula? Just now I told, summation of x by n. X is the observation and number of observations. Historical example. A historian studies the annual tax revenue in lakh rupees collected by a kingdom over 5 years. Okay, this is the tax revenue and it can be calculated by first adding all the values and then divided by the number of items. 1, 2, 3, 4, 5. So this is 100. So how can we interpret? The kingdom collected an average annual tax revenue of rupees 100 lakh during 1851 to 1855. Now median. How can we use this median? So what is the definition of this median? The median is the middle value when the observations are arranged in ascending or descending order. So it is the middlemost value when the observations are arranged in ascending or descending order. So it divides the data into two equal halves. So example, suppose the land holdings in acres of 7 farmers are like this. Through your data report, you got these informations. The land holdings in acres of 7 farmers. Okay, so we first task is to arrange in order of magnitude. It is already given in order of magnitude from the smallest to highest, ascending order. Now what is the middlemost value? It is the 15 because 3, 3, 6, 7, seventh item, that is 15. So 15 is the median acres. Notice that one farmer owns 100 acres, but the median is 15. So if we take the mean land holding, it does not provide the accurate because 100 is there. So mean will be much more higher than. Okay, it does not reflect the mean. Actually the holding, land holdings, okay, on an average. So here the median will be the right appropriate average as far as the wealth distribution, the land holdings, etc. are concerned. In that time we can apply the median. Okay, so median is right. The typical farmer owned 15 acres, making the median a better measure than the mean when extreme values exist. Okay, historical importance. Historians often use the median while studying land ownership, wealth distribution, household income, because a few wealthy individuals may distort the average. Okay, it is clear. Few wealthy individuals may distort the average. That is why median is the appropriate measure for such kind of analysis: land ownership pattern, wealth distribution, household income. Now mode. What is the mode? The mode is the value that occurs most frequently. Historical example, it is already explained at the time of that image explanation. So occupation recorded in a village census. Farmer, number of people, 120 people are farmer. Weaver 45, blacksmith 15, potter 20. So the mode is farmer. Since highest number of frequency is farmer, mode is farmer, since it occurs most frequently. Another numerical example is like this: 40, 45, 45, 50, 55, 60. So only 45 two times. So mode is 45. Interpretation, how can we interpret this? The most common occupation in the village was farming. In the first case, here maybe 45 is the answer. Standard deviation. Standard deviation is a measure of dispersion or variability. It tells us how far the observations are spread around the mean. A small standard deviation means the observations are close to the mean, indicating consistency or stability. A large standard deviation means the observations are widely scattered, indicating high variability. This is especially useful in historical research because it helps determine whether historical events or phenomena were stable or highly variable over time. So standard deviation plays an important role to explain whether the historical events or phenomena were stable or highly variable over time. How the formula, how to calculate the standard deviation? Here the formula is here. For the sample standard deviation is on the basis of the data. First we need to put the each value of the data minus it's the mean value, then squaring this divided by n minus 1. N is the total number of observations, and then square root of this value. Okay, x is the each observation, x bar is the sample mean, n is the number of observations. So from the data we need to calculate first the mean value, then we need to subtract the mean value from each value, then squaring, then sum of that square, and then divided by n minus 1, and then square root, take the square root. All these steps involved. So with the basis of this formula we can easily calculate standard deviation, and then we can able to compare among the two kingdoms or two kings or two countries or two emperors. Okay. The hypothetical historical example: a historian studies the annual wheat production in 1,000 tons of a kingdom over 5 years. So this is the hypothetical data. For the record, the historian, the scholar got this wheat production of a kingdom. Okay, hypothetical data. Now calculate the mean. First you calculate the mean, 100,000 tons. Then calculate the deviation. How to calculate? This is the data. This is the mean value. Subtract the mean value from each value. Okay, so 90 minus 100, that is minus 10. In this way we can able to calculate the deviation. This is known as deviation, x minus x bar. Squaring the deviation, so minus 10, squaring this minus 10 is 100, squaring this minus 5 into minus 5, that is 25, 0 into 0 0, 5 into 5 25, 10 into 10 100. So squaring. Okay, after that adding the square deviation, we are adding. Okay, so all this is 250. After that our total observation is 5, so 5 minus 1, so that is 4, so that is 62.5. Then this is a square, we have to take square root of this is 7.91. so this is the standard deviation. Okay, this is the standard deviation, 7.91. The average wheat production is 100,000 tons, and yearly production typically differs from this average by about 7.9 thousand tons. So this is the interpretation. Average wheat production is 100,000 tons, and yearly production typically differs from this average by 7.9 thousand tons, since our standard deviation is 7.9. This indicates moderate year-to-year variation in agricultural production, moderate variation. Similarly, another kingdom, you got data, just applying the same formula, mean, standard deviation, we can able to calculate 1.6. So the production is very stable. So the first case 7.9, and this is the variation is 1.6. The production is very stable. There are no major disruptions such as droughts, wars, or famines. Okay, in this way historian can able to predict about this phenomenon. Okay, another one, kingdom B, this is 31.6. okay, standard deviation. So how can we interpret? Although the average production is the same as in kingdom A, average production is 100 kingdom B, average production is 100 in kingdom A also. Average production, mean production is same in 5 years, but the standard deviation is 31.6 for kingdom B. Now how can you interpret? The interpretation is like this: although the average production is the same in kingdom A and B, but the production fluctuated greatly. Such variation might have resulted from repeated droughts, floods, wars, or political instability. So this is the task of the researcher, to search what are the main reasons for such kind of fluctuation, okay, in the production, wheat production. So this is the work of the researcher. Similarly, why standard deviation is important in historical research? Historians use standard deviation to measure the stability or variability of historical phenomenon, such as the agricultural production were harvest stable or erratic, tax revenue was government income consistent over time, population growth, did population increase steadily or fluctuate because of epidemics and wars, prices, were food prices stable or highly volatile, rainfall, did climatic conditions remain consistent across years, trade, was export or import volume stable or affected by external shocks. So these are the many research questions. Okay, so this, to solve these research questions, we know research questions is one of the important part in any kind of research in social science. So these are the research questions. How to solve these research questions? So we need to apply this tool, standard deviation, to give the answer of such kind of research question. Now, standard deviation measures how much the observations differ from the average. A small standard deviation means the values are close to the mean. A large standard deviation means the values are vary widely, as already explained by taking kingdom A and kingdom B. Now coming to percentage. Percentage, the definition: percentage expresses one quantity as a proportion of the whole. The formula is part by whole into 100. How can we explain this? Historical example: a census recorded total population is 50,000, literate people is 8,000. So percentage of literate is 8,000, that is part by total 50,000 into 100, 16%. In this way we can able to apply the statistical tool for calculation of the percentage of literate. Okay, so and now how can we interpret? Only 16% of the population was literate. So historians often calculate percentages of literacy, urban population, military recruits, religious groups, occupational groups. So for any kind of analysis, whenever you are going to calculate the percentage, you need to apply this rule. Growth rate definition: growth rate measures how much a variable has increased or decreased over time. Now what is the formula? The formula of growth rate is new value minus old value divided by old value into 100. The historical example: the population 1900 this, in 1910 this. So how can we calculate the growth rate? Final value minus initial value divided by initial value into 100, 20%. How can we interpret? The population increased by 20% between these two periods, 1900 and 1910. Within these 10 years, 20% increase of population. So growth rate can also be calculated for many other variables: population, export, import, industrial production, railway length, GDP, literacy, school enrollment. For any kind of variable that is required for the researcher, we can able to apply this one. So how can we summarize the total analysis? What are the measures? So far we have discussed in this video: mean, median, mode, standard deviation, percentage, growth rate. So what is the meaning? Average value. Mean means average value. Okay, so historical example: average annual tax revenue. Interpretation: typical level over a period. Median, middle value, it is also middle value. Generally, historical example: land holding sizes. For land holding, wealth distribution, wealth holding, we can able to apply median because it does not distort with the presence of huge value, one or two high value. The typical observation: unaffected by extremes. Mode: most frequent value, most common occupation. In historical example, it is used to mode. It identifies the dominant category. Standard deviation: disruption or dispersion around the average, how or fluctuation or variation among the with respect to the average. Annual crop production, historical example, it shows economic or demographic stability and volatility. Percentage: it is the part of a whole. Literacy rate, we can able to apply for calculating literacy rate. It compares groups relative to the total. Growth rate: percentage change over time. Population growth measures historical progress or decline. So relevance in historical research: these descriptive statistics help the historians answer questions such as: what was the average tax revenue during a ruler's reign, that is mean, we have to apply this tool. What was the typical size of land holdings in a village, we have to apply median. Which occupation was most common in a medieval town, we have to apply the rule statistical tool mode, where agricultural yields stable or highly variable over time, we have to apply standard deviation, this formula. The what percentage of population was literate or urban, percentage. How rapidly did population, trade or industrial output grow across decades, growth rate, we have to calculate, apply the growth rate. So these measures transform historical records into quantitative evidence, enabling historians to identify patterns, compare periods, and support interpretation with data. So with this, I'm concluding the first part. So in the next part, the more will be discussed. Thank you for your patience hearing. So that's all from today.